Welcome to the section on asynchronous code and promises. This section will be essential for you if your goal is to write code that interacts with a server through an API, as well as in case of nesting callback functions. In general, there are many asynchronous operations out there in client-side and full-stack JavaScript development that need to be handled in a maintainable way. You will learn all the tools you need to handle these callbacks in a nice, compact, easy-to-understand manner. We will start with the definition of a problem in JavaScript called the pyramid of doom, also known as the callback hell. We will then introduce promises in JavaScript to solve this problem. You will then learn about other language constructs to handle asynchronous operations, generator functions, and the ES 2017 Async-Await language construct. This functional programming course is unique because beyond getting the fundamentals, we are also using the latest language constructs of JavaScript. Previously, we only used ES 2015 constructs, but now in this section, you will find out more about an ES 2017 construct, Async-Await. In this video though, we will only target understanding the problem the pyramid of doom presents. We will start with a linguistic time travel to the past when jQuery lowered the entry barrier to front-end development. Oddly enough, we will still use some features of ES6 to spice up our code. After this example, we will generalize what the callback hell looks like. We will conclude this video with techniques we will learn in the rest of this section, not only to combat the callback hell, but also to make sure we can elegantly handle asynchronous code in JavaScript. We will use jQuery now to construct the pyramid of doom. Don't worry, you don't need to know jQuery at all to understand this example, and I will not attempt to teach you jQuery either. If you would like to follow the example with me, just go to jQuery.com and paste the code in the console of your developer tools. jQuery is a library where we write selectors to select a container of DOM nodes. Imagine the $sign as a shorter alternative of document.querySelectorAll. The rules for formulating the selectors are also similar to jQuery. You can place tag names, class names, IDs, and other types of pseudo-selectors in the selector string. The return value of the $function is a container of nodes. jQuery is a language with a monad-like structure. Executing the jQuery selector operation on the div selector yields a container of all DOM nodes. We can refine this selector by keeping those divs only that have a line class. The find function takes a selector and returns the same type of container with less elements than before. We can continue chaining calls after each other. For instance, we can get the children of all elements in our container. We get a collection of all the child nodes. The type of collection containing our DOM node references is called a jQuery wrapped set. When thinking about the children operation, imagine that a parent may have multiple children. The result is still flattened, so children essentially maps a collection of DOM nodes to a flattened collection containing all their children. Just recall the flatMap function in the video on monads in the previous section. This small description may shed some light on why I said that jQuery selectors behave similarly to monads. Let's describe the markup of our example. We place 5 elements in the DOM. A text input where the user may enter a search expression. A button to initiate calling an AJAX request of the Google Books API. An unordered list of search results. A heading describing that a preview is coming. A div containing the image preview of one of the books in the unordered list. Our application will work as follows. The user may enter a search expression and click Get Data. The click triggers an AJAX request that asynchronously returns the top 10 books matching the search expression. The title of these books will be placed in an unordered list. When the user clicks a title, the preview thumbnail image will be placed inside the last div of the page. We will place the markup inside the inner HTML of the document body. Let's continue with click handling. We will use the click method. This click handler accepts a callback function. Inside the click handler callback, we retrieve the search expression and make sure that we encode the result as a URI component. We will, for instance, replace all spaces in the expression with %20. Our next task is to fire an AJAX GET request using jQuery.get. The first argument is the URL of the GET request. We will use the public Google Books API, and all we need to do there is insert the encoded title in the query string. The second argument is a callback function where resp contains a JavaScript object describing the JSON response. We can console log this response for now. Let's stop for a moment. Can you see the foundations of a pyramid developing? Just tilt your head 90 degrees to the right. Callbacks inside callbacks. This is the pyramid of doom. After the initial surprise, let's move on and assemble the list items. If you study the response a bit, you can conclude that resp.items contains an array of books. Each book has a volume info member. Inside the volume info, you can find the title of the books and some image links containing the thumbnail. Be warned that some books don't have image links, so we will have to guard this in the code. We have to map each item to a list item containing an image link source for future use and the title. We will describe each list item in an ES6 template literal. We place the guarded image link in the data thumbnail attribute of the list item, and the text node inside the list item is going to be the title of the book. The mapping yields an array of strings describing list items. We can join these list items to get the final result. In order to display the list items, we can insert them in the JS search results div. Let's build our pyramid of doom a bit further by defining a click event on the click items. Once the user clicks a book title, we have to extract the data thumbnail value from the clicked item. We can retrieve a wrap set of the clicked item by wrapping event.target with jQuery. Our last task is to insert the thumbnail in the book image preview div. Let's test the final application. After entering an expression and pressing the button, book titles appear in an unordered list. Once we click a book, its thumbnail is displayed at the bottom. This code is by far not perfect, but we will stop here for now. Notice the structure of the pyramid of doom. Callbacks inside callbacks. The callback hell is hard to read, hard to debug, extend, test, and performing abstractions on code like this is very hard. This code structure encourages copy-pasting and slightly modifying similar callbacks. Instead of using compact 2 to 10 lines long functions, we nest all our application logic in one big chunk of code. Technically, we could disassemble the pyramid by naming each callback inside the function and flattening the code structure. This would not increase readability much though, as our code would look like a fighting fantasy game book from the 1980s. Just imagine, if an event happens, turn to line 355. If the user clicks, turn to line 49. Doesn't sound too encouraging to read or maintain. Before concluding this video, I would like to make it clear that our real problem is not callback hell. The pyramid of doom is a mere symptom of a more complex root cause. Ultimately, our goal is to elegantly and efficiently handle asynchronous functions with callbacks. Let it be a timeout operation, an event callback, file I/O operation, or an AJAX request. Asynchronous operations are everywhere in JavaScript. We need asynchronous callbacks inside asynchronous callbacks. This is why we will investigate some techniques to make our asynchronous code readable. In the next videos, you will encounter 3 recent additions to JavaScript that can be used to make our asynchronous code maintainable. These are promises, generator functions, and ES 2017 Async-Await.